Hey guys, I hope it's going well. We're moving right along on to lesson 6. This lesson we're going to continue with graphing sine and cosine, but we're going to look at the one part we didn't do last class, which is changing the period of those functions. So just to review, we are repeating, in a sense, what we did with the transformation of functions unit, in that we've got everything with a, k, d, and c here for cos and sine. And we're applying those things. So the one thing we didn't figure out, which is k. So A represents the amplitude, and it's always positive. That's why we give it that absolute value sign. It's the amplitude like that. Phase shift is my D value, so that's left and right. So that affects my X values. Vertical shift is C, and that's also the midline. So this is up, down, and it's the midline of the graph. And then period is represented as 360 degrees divided by K. So whatever K is. And so there's always this opposite operation kind of thing going on. It has the opposite effect. So if K is multiplication, it's actually dividing the period. Whereas if K is a fraction, it's actually multiplying the period. And we'll see that here. So let's take a look at a couple examples. So we're going to kind of figure this out by trial. And so we're going to look at what the K value does here. So I've set up two tables. One is for y equals sine x, and the other is for y equals sine 2x. Notice now this is my K. So K is inside sine, and it's sometimes in brackets like that with x. So my K value here is 2. And my period, instead of being 360, is now 360 divided by K. So 360 divided by 2, which is 180 degrees. So if I just use the basic sine function, so let's plug in values to the basic sine. So these are the key points. So if I sub in sine of 0, I get 0. Sine of 90, I get 1. Sine of 180, 0. And then negative 1 and 0. And so we can go ahead and graph that. So let's just plot that one in. We'll do a couple cycles. So I continue with my pattern of every 90 degrees, it is going up or down 1 unit. So we can connect these with a nice curve as best you can. Like that. And then, so the second one here is the function where we have the K value. So if I sub in 0, so the sine of 2 times 0, oops, 2 times 0, really that's the sine of 0, which is 0. This one's going to be the sine of 2 times 45, which is the sine of 90. And so in effect, you get the sine of 90, which is 1. So this value of sine 45 is 1. Sine of 90 would be like sine of 2 times 90, which is the sine of 180, which is 0. And you can see the pattern here. We're getting the same values, but our same y values, but our x values are divided by 2. And so I've got 2 times 135, which is the sine of 270, which is negative 1. And then this one is going to be 360, which is 0. So when we plot this, what happens, in a sense, is that instead of moving over 90 degrees, we're now moving over 45 degrees. So in the middle here, between 0 and 90, I'm up at 1. So that's this point here. And then the sine of 90, I'm down to 0. Sine of 135, which is the middle in between, is negative 1. And so on. And so I get one full cycle in half the horizontal distance. And so I can continue this pattern where every 45 degrees now, I'm going up or down 1. like that. And so again, this is y equals sine of 2x. So the thing here is that k has the opposite effect on the x values, which is the same thing as what we saw with k, with quadratic functions, with exponential functions, with everything we've done with any function thus far. And so let's do one more here where we have cosine. This time we're dividing, so we've got a k value here where it's x over k. This is the same as if I had cos of 1/2 x. Same thing, just written differently. So my k value here is 1/2. And my period is going to be 360. I'm going to write it this way, divided by 1/2, which is the same as 360 times 2 over 1, which is going to be 720. Oops. So in effect, my period has doubled even though I'm dividing it by 2. So if we take the key points for cosine here and start to graph them, so remember cosine of 0 actually starts at 1, cosine of 90 goes down to 0, then -1, 0, and back up to 1. So if we plot that one, so I start here like this. So there's 2 cycles, so it starts at the peak of the function, the maximum, and we get that. So that's my base function for cosine. Now with x over 2, cosine of 0, that's still going to be 1. It's because 0 divided by 2 is 0. This one's going to be cosine of 180 over 2, which is the cosine of 90, and that gives me the same value up here, which is 0. This one is cosine of 360 when I plug it in, divided by 2, which is the same as cosine 180, which is -1. And as you see, we're going to get the same values, but my x values in this case have doubled when I divided by 2. So if I plot that, we're only going to be able to fit in one cycle. Oops, I put that in the wrong spot. So I'm starting at 1 up here, then 180 now and going down. So instead of moving every 90 degrees up or down 1, I'm going 180 degrees. So this is y equals cos x over 2. So one key thing to remember is that there's a little algorithm we can use. When I have y equals, let's say sine, if we use that as an example, my k should always be factored out front, like that. And then my key points from, let's say, x and y, if I call these my key points, get transformed into this little algorithm where I say x over k, and you can say minus d if you want, or plus, doesn't matter, as long as you understand how it's the opposite sign. And then a times y plus c. So these are my transformed points. Again, it's the same thing we did when we dealt with transformations of other functions. So that little algorithm is key. So let's try this where we're combining a few things. So we've got, in this case, an amplitude that's changing from -4, and then my k value is also changing the period. So my k value here, if we just label it, it's 1/3. So that means my period is going to be 360 divided by 1/3, which is the same as 360 times 3. So I'm actually going to have a really long period of 1080. So when you're going to graph these, the easiest thing to do, and you'll see this in a second when I do the actual table of values, it's easiest to use a scale that goes up by the same increments as the transformed points. So for example, in the base function, we're going up by 90 degrees, but as my period changes, like here, I was going up by 80, or 180 rather. Here, I was going up by 45. Those are the increments I'm referring to. So this will make sense once we do the actual table of values. So if I take my base function, sine of x, because we're using sine, so I put in my 5 key points, and you're going to get very tired of doing this, and you're definitely going to know them very soon. So there's my key points. Now I take my new function, -4 sine 1/3 x, and I use my little algorithm. So this guy here. And so I would keep that by in order to remember it. So when I do this, my x values are now going to be times 3. So instead of divided by 3, it's times 3. So I end up with 3x. And then my y values are times a. So I've got -4y, like that. So what I need to do is to take each x value and multiply it by 3. And each y value I multiply by -4. So my first x, 0, just stays 0. 90 times 3 is 270. 180 times 3, and you'll probably need a calculator at some point, is 540. 270 times 3 is 810 rather, and then 360 times 3, which was the period length. So notice my increments that it's going up each time is plus 270. Like that. So each time plus 270. That's what I'm referring to in this part, and that's going to help determine our scale. So the y values, I simply multiply by -4. So the first one is 0, 1 becomes -4, 0, and then -1 becomes +4, and then 0. So this thing's been reflected over the x-axis. So when you have these graphs, almost all of them are going to be the same size, so that's going to be helpful. But to do the scale, what I would suggest is every 2 units here, or every 2 ticks, is going to be your increment of change, 270. And you should be able to fit 2 cycles on here. So if I do this, that means I should have 1 cycle. So the second tick would be 540, third tick is 810, and then this one is the 1080. Then I would keep going, and so that this tick would be double or 2 cycles long, so this would be 2160 degrees. And then I need a height of 4, so this could be 4, this could be 2, so each tick is 1, down to -4, like that. And then we just need to plug it in. So I got 0, 0, so I'll just do my transform function, 270 -4, and so on. So notice, this is why it's nice to have a scale where it's going up based on your increments of change, because you know it's just going to move along like that. And there we go. And so it's not so bad. A few steps to it, like doing this little algorithm, I think that's the key part to be able to do it. And then knowing the key points. So the second one here deals with cosine. So we look at it. So I've got it like in this form. The first thing you have to do is you must factor k. Again, just like we did before in other units. So I need to take this 4 out front, which now makes it a shift of plus 45. So I'm factoring the 4 from the 180, like that. And so now you have a proper D value that's going to work. So my K value here is 4. My period is going to be 360 over K. My period is quite small. And then the key points, really I'm talking about the scale. If you wanted a little calculation, you would just take your period divided by 4. So 90 over 4, which means it's going to go up in increments of 22.5. That's going to be seen when we do our key points here. So you don't necessarily need to memorize that part. So if I do my key points for cos, so again, always 0, 90, 180, 270, 360, so going up by 90s. So pretty easy to remember. If you forget what the y value is corresponding to each, you can always plug it in your calculator. So cos 0 is 1, cos 90 is 0, negative 1, 0 and 1. And then my little algorithm. So now I want y equals cos, or 2 cos. I'm going to take the factored form. So I know that this thing here is shifting left. So that means it's subtracting 45 degrees. So my x value is how it's going to be affected is I'm going to have x divided by 4, my k value, and then minus my shift, which is 45 degrees. So again, it always changes signs. And then my y values, I'm multiplying by 2. So if I was to highlight these, that's that. So this guy goes here, and then this guy changes signs there. So I take each of my x's and I do this. So I subtract 45 from 0, and then I do 90 divided by 4 minus 45, so you might need a calculator. So that becomes minus 22.5. The next one's going to be 180 divided by 4 minus 45. So that becomes 0. And then notice it's going up by increments each time of 22.5. That's always going to be the case, that you have the same incremental change as you go up by your x's. Then the y's are pretty easy. I'm just multiplying by 2. Like that. So let's create our scale. Again, I'm going to use every 2 is the incremental change. So 22.5. Notice I've got some negative values here. So I can go backwards if I want. So this will be minus 22.5. This will be minus 45. And then we can go up. And so this will be 90. Oops. That should be 180. And then we can plot everything. Sorry, there's the y-axis too. So why don't we do this? 1, 2, negative 1, negative 2. Great. Now you can plot it. So again, seeing the scale makes this much easier than if we didn't change the scale. So because now when I continue on as the pattern, I know I'm just going to each tick as I go along, like that. So my cosine starts at the top, although it's been shifted, like that. And that continues. This is y equals 2 cos 4x plus 45 brackets. Great. Okay. Hopefully you get the idea of it. You can try these few out. So I would pause the video and then I'll go through them, but this is kind of the you try section. So pause the video if you need to, and then you can check your answers. So the first one here, my k value is 1/2. Period is 360 times 2. So that's going to be 720. And so I can set up my sine x key points. Always start with the key points. Then I want the transform part. So if you are following along, see if you can at least get this part. I'll put that in brackets, doesn't really need to be. So this is going to become 2x and then y minus 2. So if I do my conversions, so that's 0, this is going to be 180, 360, 540, and 720. That was my cat snorting for whatever reason. If you're listening, if I do my y values, this one, this would be -3, yep, and then -2. So we've already got a scale here, so that's nice. So 0, -2, 180, -1, 360, -2. So we have to follow this pattern. So the next one, -540, would be -3. So what we need to do is come over here backwards like this and continue it along. And so notice my incremental change is 180 degrees for x and like that. So in this one, I only get one cycle based on the scale, which is fine. Okay. Next one, k is 2, period is 360 divided by 2. So this one's going to have a period of 180. And this time we have cos x. Fill in our key points. Starting at 1. Again, if you were following along, I would try this section out just so you can see if you get your little algorithm right. So my x is over 2 minus 90. And then my y value is times 4. So if you do those calculations, first one's going to be -90. Next one's -45, which implies that I'm going up by 45, so that's easy to fill this in. Then my y value is times 4, so I get 4, 0, -4, 0, and 4. So again, we've got the scale, so we can do this. -45, so it's somewhere in the middle of this, so that's going to be 0. 0 is -4, and so on. So when you continue this along, it's just going halfway between each. And that's kind of enough. So you can see it's really stretched vertically. And it's a horizontal stretch of 1/2. Great. And so I'll just label that. Okay, a couple more and then you can do the homework questions. So this one, I need to factor. So my phase shift is 30 degrees to the left. So my k value is 3, period's 360 over 3. So that's going to be 120. Again, my key points. And my shifted points. So I got negative sign. So my x value is divided by 3 and then subtract 30. My y value is times negative. Let me just fix that. So -y. So if I work that all out, I'll just get my values here. So this is going to be -30. It's going to be 0. So we're going up by 30. So that makes this easy. So that's 30, 60, and 90. And my y values, I'm just flipping the sign. Great. So again, to scale, I'm going up by 30. So I'm going to make this 30. So that'd be 60, 90, 120, 150, 180, 210. So that should give us enough for scale. And we're only going to 1 and positive or -1, so I'm going to do it like that. This would be -30. So we start here for sine, going down because it's been reflected. and so on. Connect them. And label our graph. And the last one here, k-value of 6. So I divide my period by 6. That gives me a really short period of 60. And my key points. And my change points. And so I'm dividing my x values by 6. Oops. That's 15, so it looks like we're going up by 15s. And my y value is a bit trickier, so that's -4, -1, 2, -1, -4. So I'm going to make each tick 50, or each 2 ticks 15. So if I plot this, 0, let's say that's -4, that's +4. 0, -4. And follow the pattern. Oops. And we're good. Okay. Hopefully that was okay. It is a bit tedious in terms of time. I understand that. So I didn't give you much homework here. You can check out your answers. You can pause this if you want and flip through. But there's the solution.